Hello coders, I welcome you all. In this video, we are going to perform data analytics using the Olympic dataset available on Kaggle. The goal is that by the end of this video, you will be able to perform data analytics on any dataset following the same process. So I have divided this video into 3 sections. In the first section, we will cover some basic questions about the data. These are the most common questions that you would typically ask when working with any dataset. In the second section of this video, we will perform univariate analysis on both categorical and numerical columns. In the third section of this video, we will perform bivariate analysis and multivariate analysis. So let's get started. So let's start with our section 1, basic questions about the data. So you can see these are the most common questions that you would typically ask when working with any dataset that you can see over here. So let's get started. Let's import the required libraries. Let's import pandas as pd, also matplotlib.pyplot as plt. Also let's import seaborn as sns. Also let's import warnings. Let's execute this cell. You can see our required libraries are successfully imported. Let's first disable the warnings. So for that we have to write warnings dot filter warnings, and here we have to pass ignore the warnings. Let's execute this cell. Now done. Now first we have to load our dataset as pandas Dataframe. So for that we have to write pd, which is pointing over here, and we have to use read_csv method of pandas Dataframe, and our dataset is available with this particular name, athlete_events.csv, that I have downloaded from Kaggle. Let's assign it to one variable data. Let's execute this cell. You can see we have successfully loaded our dataset as pandas Dataframe. So let's start with our question number 1. Here we have to display top 5 rows of the dataset. So for that we have to use head method of pandas Dataframe. Let's execute this cell. So as you can see, top 5 rows of our data set. So this head method in pandas is used to display the first few rows of a data frame or data set. By default, it shows the first 5 rows of the data set that you can see over here, which helps you quickly understand the structure and the content of your data set that you can see over here. So this way we can display top 5 rows of the data set using head method of pandas Dataframe. Now let's move on. Our second question. Here we have to display last 5 rows of the dataset. So for that we have to use tail method of pandas Dataframe. Let's execute this cell. You can see last 5 rows of our data set. So this tail method in pandas is used to display the last few rows of a data frame or data set, the end of your data set that you can see over here. This allows you to quickly verify the final entries in your data set that you can see over here. By looking at this, we can say that total we are having this many rows or this many samples in our data set that you can see over here. So this way we can display last 5 rows of the data set using tail method of pandas Dataframe that you can see over here. Now let's move on. This is very important function. Here we have to print random 5 rows from our data set. So for that we have to use sample method of pandas Dataframe. Let's execute this cell. So as you can see, by default sample method is displaying only one random row from our data set that you can see over here. But as per our question, we have to print random 5 rows from our data set. So here we have to pass one argument. So here we can pass one integer value like 5. Let's execute this cell. You can see over here. Now this function is displaying random 5 rows from our data set. At every run, it will fetch few random 5 rows from our data set that you can see over here. Let's execute this cell one more time. You can see random 5 rows. This function is fetching random 5 rows from our data set. So as per your requirement, you can fetch any number of rows, 5, 10, 20, any. So as you can see, currently this sample method randomly selects 5 rows from the data frame, allowing you to get a quick snapshot of the dataset without any bias. This is helpful for checking the variety in your data that you can see over here. So this way we can print random 5 rows from the data set that you can see over here using this particular method, sample method of pandas Dataframe. Now let's move on. Now our question number 4. Here we have to find the shape of our data set, means number of rows and number of columns available in our data set. So for that we have to use shape attribute of pandas Dataframe. As you can see here, Output is Python tuple. This is at index 0 and this is at index 1. Means our data set contains this many rows and this many columns that you can see over here. So this way we can find the shape of our data set using shape attribute of Pandas data frame that you can see over here. Now let's move on. Here we are going to check for null values or missing values in our data set. So for that we have to use isNull method of Pandas data frame. Let's execute this cell. As you can see, output is Pandas data frame with Boolean values. Now let's perform sum of true values using this sum function. Let's execute this cell. As you can see over here. So this returns the count of null or missing values for each column that you can see over here. 0 means no missing values. But here you can see in our data set, each column contains some missing values. Same for height and weight as well. And also for this medal column that you can see over here, right? But please remember here in the medal column where a missing value indicates that no medal was won. Please remember this. So in our case, since the missing values are meaningful and indicate a specific state, no medal, we should retain them as they are instead of filling them in. Please remember this. Here values are missing. It represents no medal. Please remember this. So we are going to fill missing values for these particular columns, age, height and weight. Not required for medal because here missing values indicate a specific state, no medal. Right? Before we move forward, let's fill missing values in these particular columns, age, height and weight. And we are going to replace null values or missing values with mean of that particular column. To check the column names, we can use this particular attribute of Pandas data frame, data.columns. So now let's fill missing values first in this age column. For that, we have to use fill NA method of Pandas data frame. So as I said, we are going to fill the missing values with mean of that particular column. And to modify our existing data frame, we have to assign back. Same we have to do for height and weight as well. Let's copy this column name. Let's paste it over here, here and here as well. Let's copy this weight column. Let's paste it over here, here and here as well. Let's execute this cell. Let's check. Let's copy this statement and let's paste it over here. You can see. We can say we have successfully filled missing values in these particular columns, age, height and weight. Hope all of you are clear with this. So this way we can check for missing values in our data set that you can see over here. Now let's move on. Here we have to get information about our data set like total number of rows, total number of columns, data types of each column and memory requirement. That we can do with just one method. Info method of Pandas data frame. You can see over here. Total we are having this many entries. Means this many rows. With this index. Total we are having 15 columns. You can see column names and we are having this many non-null values in this particular column. This many non-null values in this particular column that you can see over here. So using this info method, we can also check for missing or null values that you can see over here. And also we can see data types for each and every columns that you can see over here. And here you can see D types column means in our data set 3 columns with floating point data type, 2 columns with integer data type, 10 columns with object data type. Object means string, right? And memory usage of our data set. Storage is required for our data set that you can see over here. So this way we can get information about our data set like total number of rows, total number of columns, data types of each column and memory requirement using info method of Pandas data frame that you can see over here, right? So as I said, we are going to use Olympic dataset, this dataset which is available on Kaggle. So you can download this dataset from Kaggle, means from here or from my GitHub account. Link is provided in the description of this video. This dataset contains 120 years of Olympic history, athletes and results that you can see over here. And these are our columns or features. ID, unique number of each athlete. Name, athlete's name. Sex, means gender, male or female. Age, which is integer. Height, weight, team name, NOC, National Olympic Committee, which contains 3-letter code. Games, year and season. Year, which is integer. Season, summer or winter. City, host city. Sport, event and medal. gold, silver and bronze, or NA, no medal, right? So these are our columns or our features available in our data set, and you can download this data set from here by clicking on this particular button, download button, that you can see over here. Now let's back to Jupyter notebook and let's move to our next question. Here we have to get overall statistics about our data set. So for that we have to use describe method of Pandas data frame. You can see. So by default, this describe method in Pandas provides a summary of the numerical column in our data set. It returns statistical measures such as count, mean, standard deviation, minimum, maximum and quartiles values that you can see over here. Let's take this particular column age. So count, total number of rows in this particular column, average value of this particular column, standard deviation of this particular column, minimum value available in this column that you can see over here. You can see athlete with age 10 years that you can see over here. And these are percentile values 25%, 50% and 75%. Means in this age column 25% values are below this particular value 22. In this age column 50% values are below this particular value 25. In this particular column age 75% values are below 28. You can see, and you can see maximum value in this particular column age, which is 97, right? It is potential outliers that you can see over here. Athlete age of 97, right? So by looking at these statistical measures, we can find many things that you can see over here. Also, we can able to see potential outliers, but still we have to perform more analysis before considering it as an outlier. Hope all of you are clear with this. How to get overall statistics about our data set that you can see over here. Now let's move on. Here we are going to check for duplicated rows. So please remember, it is a best practice to check for duplicated values in our data set before feeding it into a machine learning model. Duplicate entries can introduce several problems. To check for duplicated values in our dataset, we can use duplicated method of Pandas. Let me show this. So for that, we have to write data dot duplicated method of Pandas. Let's execute this cell. You can see output is Pandas series with Boolean values. Let's perform sum of true values. You can see here these many entries means these many rows are duplicated in our data set. Now let's display duplicated rows. So let's copy this and let's paste over here in our data set. Let's execute this cell. You can see over here rows are exactly same that you can see. These many rows are duplicated in our data set that you can see over here. So now let's remove this duplicated rows. So for that we have to use drop underscore duplicates method of Pandas data frame. To modify our existing data frame, let's assign back. Let's execute this cell. Now done. Let's check it once. Let's copy this and let's paste it over here. Let's execute this cell. As you can see, we have successfully removed duplicated rows from our data set that you can see over here. Also, we can check shape of our data set. You can see number of rows are less as compared to our previous analysis. Can you see? And current, right? Hope all of you are clear with this. Now let's move on. Here we are going to perform correlation analysis. So correlation analysis helps us understand how different features in our data are connected to each other. This understanding allows us to choose the best features, improves our model's performance, and makes our results easier to explain, leading to more successful machine learning projects. So it's always good practice to perform correlation analysis. Again, we can perform only on numerical columns. So first, we have to select only numerical columns. Using this method, select underscore d types, include only numbers, and let's assign it to one variable numerical data is equal to this statement. Let's execute this cell. Now let's calculate the correlation matrix. So for that, we have to use this core method of Pandas data frame. Let's execute this cell. You can see here our correlation matrix. Also, we can visualize this. Let's copy this and we have to use SNS heatmap and we have to pass this inside. Let's execute this cell. You can see over here our correlation matrix using heat map of Shibon. So the question is what it shows. This matrix represent the Pearson correlation coefficients between the different features that you can see over here: ID, age, height, weight, and year. So here is the explanation for correlation matrix. So what it shows, this matrix presents the Pearson correlation coefficients between different features in our data set. The coefficients range from -1 to 1, indicating how strong features are related. And here is the interpretation: 1 or -1. Perfect correlation, either positive or negative. 0 means no correlation. Now next, positive values. If positive values, it indicates that as one feature increases, the other tends to increase as well. Negative values, it indicates that as one feature increases, the other tends to decrease. That you can see over here. These values are between -1 to 1. Let's understand some of the values. You can see here height and weight. This you can see positive correlation, which is near to 1, right? So there is a strong positive correlation between height and weight, meaning taller individuals tend to weight more. That you can see here. Now let's take age and weight, and here you can see weaker positive correlation because number is far from 1. A weaker positive correlation suggests that as age increases, weight may also increase slightly. That you can see here. Now age and height, again a very weak positive correlation, indicates minimal relationship. That you can see. Hope you can understand. You can see ID and age, which is a near to 0. A near 0 negative correlation suggests there is almost no relationship between these two variables. Obviously, right? Athlete's ID is not related with age. This is just for your explanation, right? In summary, this matrix helps identify relationships between features using Pearson correlation, right? And these values are in between -1 to 1, right? You can use this explanation. So same information we can get from this heat map as well. Here darker color indicates lower relationship and lighter color indicates higher relationship. That you can see here, which represents exact same information but in form of heat map. That you can see over here. Hope all of you are clear with this. How to perform correlation analysis. Now let's move on to our section 2, univariate analysis. So here we are going to take one variable at a time and perform our analysis. As you know, there are two types of data in our data set, categorical and numerical. Therefore, we need to perform analysis according to the data type. So first, we are selecting categorical data from our data set and we will perform univariate analysis. Let me display first row of our data set. So here you can see name, which is categorical column having many categories, sex, which is again categorical column, age, height, weight, these are numerical columns likewise, right? So as I said, there are two types of data in the data set, categorical and numerical, that you can see over here. So therefore, we need to perform analysis according to the data type. So first, we are going to perform univariate analysis using categorical data. Then we will move to the numerical data. So let's start with this particular column, sex or gender. So now just think, using this column sex or gender, what question would you ask as per our data set? For example, a common question might be how many male and female athletes participated, right? So this is our first question. We have to find distribution of athletes by gender. First, let's display column names and we want to work on this particular column, which is categorical, sex. You can see on the categorical column, first method that you can use is value counts. You can see. So value counts is a method in the Pandas library used to count the unique values in a series. In a Pandas series, it returns a series containing the counts of unique values sorted in descending order. In our data set, total we are having this many male athletes and this many female athletes that you can see over here. So now it is always better practice to visualize it, right? So first, let's copy this, let's paste it over here and let's assign it to one variable. gen underscore dist for distribution. Let's execute this cell. On x-axis, we want male and female. That we can do like this. We have to use index attribute. You can see, let's copy, let's paste it over here, and values on y-axis. That you can see. Here, let's use bar plot. So please remember, when you have any categorical column, first plot that you can use on categorical column is bar plot. So on x-axis, we want this index. On y-axis, we want these values. Let's execute this cell. You can see male and female. Also, you can set figure size. This is the method of matplotlib that we have already imported. Matplotlib.pyplot as plt. We have to use fig size. You can pass any number as per your requirement. You can see. Also, we can set title using plt.title. Gender distribution in the Olympics. Let's set x label as well and y label as well. On x-axis, label will be gender. On y-axis, count. And just to remove this extra information, let's write plt.show. Let's execute this cell. Now it's look better, right? So you can see this plot indicates male participation in the Olympics is higher compared to female participation. That you can see over here, right? Now tell me which plot to create first when you have any categorical columns, bar plot, right? Now let's move on. Let's display first row of our data set. So now let's take another categorical column. Just think, using this column sport, what question would you ask as per our data set? A common question might be, which sports have the highest number of participants, right? So in this way, you can keep asking questions and try to gain insights from the data, right? Currently, we are working on categorical columns. Shortly, we will take numerical columns as well, right? So here is the question. As per this particular column, sport, which is categorical column, here we have to display the top 10 most popular sports based on athlete participation. Again, if we have categorical column, like sport, first method we can use is value counts, right? You can see we are interested in top 10, right? Let's assign it to one variable top is equal to this statement, right? And again, currently we are working on categorical data. We can use the most common plot in categorical column. Which one? Bar plot, right? To save our time, let me copy this code. Let's paste it over here. In place of this, we have to use top. Here is also, let's change title to top and sports by participation. Here is number of athletes and sport. Let's execute this cell. You can see overlapping, and let's exchange this. Values on x-axis and index on y-axis. Now it's look better. So you can see the top 10 most popular sports based on the athlete participation that you can see over here. Right? You can see by looking at this plot, we can say that athletics is the most popular sport based on athlete participation in our data set that you can see. So this is the most common plot that we can create on categorical data. Same if we want to visualize the percentage of athlete participation in different sports, we can use a pie plot, which is the second plot that we can use on categorical data. Let me show this. So again, let's copy this. Let's paste it over here. And here, plot and kind pie plot. Let's execute this cell. You can see we want percentage inside this plot. So for that, we have to use this parameter, auto PCT equal to percentage 1.2 F, 2 decimal points after number. Let's execute this cell. Oh, here is comma. Sorry for this. Let's execute this cell once again. You can see, so in this pie chart, about 25% of athletes are in athletics, making it the most popular sport. And you can see, second one, gymnastics, is around 70% of athletes, showing it's also quite popular, right? Now you can understand which plot to create first when you have categorical columns, a bar plot, right? And another plot you can create for categorical data is a pie chart or pie plot that you can see over here. Hope all of you are clear with this. Now I'm sure you can perform univariate analysis if you have any categorical column, right? Now let's move on. Here we have to find the most popular sport based on the athlete participation. We are interested in name of sport only, right? So first, let's display first row of our data set. So as per our question, we have to work on this particular column, sport. Let's copy this. Let's paste it over here. Let's execute this cell. And this is categorical column. So we can use value counts, right? And we have to find the most popular sport based on athlete participation. So for that, we can use very important method, IDX max. Let's execute this cell. You can see this is the most popular sport based on athlete participation, athletics, right? So let me show you how IDX max works. Let's copy this. Let's paste it over here. Let's execute this cell. You can see. So please remember this IDX max returns the index of the first maximum value. This is the first maximum value and this is the index of the first maximum value. That's why it returns this, right? Hope all of you are clear with this. So you can see the most popular sport based on the athlete participation is athletics with this many athletes. Hope all of you are clear with this, right? So this way we can perform univariate analysis if we have any categorical columns, right? Now let's move on to numerical columns. How we can perform univariate analysis on numerical columns, right? So let's first display first row of our data set. And these are our numerical columns. Let's first select age, right? So we can find the minimum, maximum, and average values of this particular column, numerical column, like age, right? Additionally, we can divide this data into ranges, such as age groups, like 10-20 and 30-40 likewise, which allowing us to represent this information using bar plots. This approach also helps us understand the distribution of the data. So please remember, first plot that you can plot if you have any numerical column in your data set is histogram or hist plot of seaborn. And this is our first question. After that, you will understand this. Here we have to check the distribution of age. So for that, let's first select one numerical column, age. Let's copy this. Let's paste it over here. Let's execute this cell. You can see, and let's use seaborn's hist plot, histogram. You can see, let's make it better. Let's select bins to 20. Now it's look better, right? And also we can use KDE plot as well. So here I'm making KDE to true. Let's execute this cell. You can see. Also we can set title and labels that you can do, right? Also we can set figure size as well. So here you can see on x-axis age and y-axis count. So this bar indicates the frequency of athlete ages in different bins or age groups that you can see. And here we have used KDE, kernel density estimate curve, this blue line, right, which represents a smooth version of the age distribution, helping visualize overall pattern that you can see, which is KDE plot. So from this plot, you can see the distribution is right skewed or positive skewed, right, because tail is over here, meaning most athletes are younger that you can see and fewer are older at this side, tail side. So this is positively skewed and the peak occurs around age 20 to 25 that you can see, suggesting this age group contains the highest density of athletes. So here the highest density between ages 20 to 25. There are very few athletes older than 40 that you can see and almost none after age 80 that you can see, right? So please remember, this is the most common plot that you can create on any numerical column if you have in your data set histogram or hist plot, right? Another most common plot that we can create on numerical data is box plot, right? Let me show this. So for that, again, I'm using age column and box plot. So x is equal to data age. Let's execute this cell. You can see this is our box plot. So this is Q1, this is Q2, this is Q3, and this is IQR, interquartile range, which is Q3 minus Q1, right? This, which is IQR, interquartile range. So this is whiskers, lower bound and upper bound, which represents minimum and maximum values, which are calculated like this. Like here, Q1 minus 1.5 into IQR, interquartile range, which is Q3 minus Q1, right? And this is maximum, which is calculated using Q3 plus 1.5 into interquartile range, IQR, that you can calculate like this, Q3 minus Q1, which is IQR, right? Okay, so this is lower bound and this is upper bound, called as a whiskers. So data points that are fall outside the whiskers here and here are considered potential outliers, but further analysis are required. And you can see these values are significantly deviate from the rest of the data set. So that's why we are considering this as potential outliers. Hope all of you are clear with this, right? And these are percentile values, Q1, Q2, and Q3, right? That we have already discussed, 25%, 50%, and 75%. So in our data set, 25% values are below this, 50% values are below this, and 75% values are below this. Hope all of you are clear with this, right? Now I'm sure you can perform univariate analysis if you have any numerical column in your data set, right? So the most common plot we can use on numerical columns is hist plot, histogram, and box plot. There are many, but these are the most common plots, right? Now let's move on. So as I said, for numerical columns, we can find the minimum, maximum, and average values. And also we can check for skewness. Let's use age column. Let's copy this. Let's paste it over here. And minimum value in the age column, 10. So the youngest athlete is 10 years old, max. The oldest athlete is 97 years old, right? In our data set. Average value is around 25 years. Right? So the average age of athletes is approximately 25 years, right? And also we can find skewness. So please remember, a skewness value of 0 indicates a perfectly symmetrical distribution or normal distribution. Greater than 0 indicates right in our case, which is positive skew. So this column is positively skewed, that you can see. Right tail is longer than left, more younger athletes, right? If this value is less than 0, indicates the left tail is longer than the right, which is negative skew. Hope all of you are clear with this. So this way we can find minimum, maximum, and average values for numerical columns. And also we can check for skewness like this, right? I hope all of you are clear with how to perform univariate analysis if you have categorical data or numerical data, right? Now let's move on to our next section, section 3. Here we are going to perform bivariate and multivariate analysis. So in bivariate analysis, we are taking two variables or two columns at a time and perform our analysis, which is called as bivariate analysis. In multivariate analysis, we are taking more than two columns or variable at a time and perform our analysis, which is called as multivariate analysis. So in bivariate analysis, we take two variables at a time and perform our analysis, right? As we just discussed, the variables can be either numerical or categorical, right? In the first combination, we assume that both are numerical, and then we explore how to perform the analysis, right? So first, we are going to examine these particular relationships when we are having two numerical columns. Shortly, we will examine this combination, numerical and categorical. Then finally, we will examine the relationships between categorical and categorical columns, right? So let's start with numerical and numerical relationships. So please remember, first plot that we can create if we have two numerical columns is scatter plot. Please remember this, scatter plot, right? So again, I'm going to use Seaborn's scatter plot. Before that, let's display first row of our data set. So on x-axis, let's take age. On y-axis, let's take height. This two numerical columns, age and height. Here data is equal to our data frame. Let's execute this cell. You can see over here. So for better understanding, let's set figure size. Now it's look better. So you can see here both variables are numerical, age and height. Age on x-axis and height on y-axis. So you can see this scatter plot shows the relationship between age and height. So here each point represents an individual which their age on x-axis and their height in centimeters on y-axis that you can see. So from this scatter plot, we can say that most data points are concentrated between the ages of 20 and 40 years that you can see, and around the height range of 160 centimeter to 180 centimeters, right? And here you can see younger individuals shows a wider variation in height that you can see here, this section. And as the age increases, the height variation decreases and becomes more consistent here in this part. Let's talk about outliers. There are fewer individuals with extreme heights, very tall or very short. And you can see as age increases with some noticeable outliers, especially among younger and older ages that you can see. So this way we can perform bivariate analysis if we have two numerical columns that you can see, and we can find relationships between them, right? Hope all of you are clear with this. Also, we can perform multivariate analysis as well. So for that, let's use hue parameter. Let's execute this cell. Now you can see, now we have three variables, age, height and sex, means gender. Now you can see here blue dot indicate male and orange dots indicate female. And you can see males are generally taller than females, with males mostly between 160 to 200 centimeters and females between 140 to 180 centimeters in height, right? So variation decreases with age for both males and females. There is significant overlap in the 160 to 180 centimeters range, right? So this way we can interpret this graph, and this way we can perform univariate and multivariate analysis, right? Hope all of you are clear with this. Now let's move on. So here we are going to perform bivariate analysis using numerical and categorical columns. So here I want to show you how you can perform bivariate and multivariate analysis if you have numerical and categorical column. Means you want to find relationships between these two columns of numerical type and categorical type. So let's display first row of our data set, and here we can use bar plot. On x-axis, let's select middle, which is categorical column. On y-axis, let's select age, which is numerical column, and data is equal to data, which is pointing to our data frame. Let's execute this cell. You can see our bar plot. Also, you can set figure size, title, X label and Y label as well, right? So this bar chart shows the average age of individuals by medal type, gold, bronze and silver. So the average age for each medal type is very similar, that you can see, around 25 years. So there are no significant difference in the average age among gold, bronze and silver medalists that you can see. In summary, athletes across all medal types have nearly the same average age that you can see. So this way we can perform bivariate analysis to check relationships between two variables. And here we are considering one numerical and one categorical column that you can see. So the plot that we can use is bar plot. Another plot that we can use if we have one numerical and one categorical column is box plot. Let's change it to box plot. Let's execute this cell. As you can see, hope all of you are clear with this, right? These are the most common plots that you can use for the bivariate analysis if you are one column of type categorical and one column of numerical type that you can see, right? And here also we can perform multivariate analysis by introducing third variable, sex. Let's execute this cell. You can see, so this chart shows the ages of male and female athletes who won gold, silver and bronze medals that you can see. From genders typically range from their mid-20s to early 30s, with a few younger and older outliers that you can see. So the age distribution is similar across all types of medals, right? Hope all of you are clear with this. How to perform bivariate and multivariate analysis if you have one column of type numerical and another column of type categorical, right? So we can use most common plots like bar plot or box plot, right? Now let's move on. Now here, what if we have one column of type categorical and another type is also categorical? Then how we can check relationships between these two columns? So here is the question. How many gold, silver and bronze medals have been awarded to male and female athletes, right? So first, we can use cross tab, and data I'm using sex column as per our question and medal column, right? Because as per our question we have to find how many gold, silver and bronze medals have been awarded to male and female athletes. So male and female that we can get from the sex column and medals from this column medal. And here I'm using cross tab, right? Let's assign it to one variable con. Let's execute this cell and let's print this contingency table. You can see bronze medal count for female, gold medal for female, likewise for male, bronze medal, gold and silver medals that you can see. Also, we can plot this using heat map of seaborne. Here we have to pass this cross tab. You can see, right? So here darker color indicating lowest value and lighter color indicates higher value that you can see for male and female. Also you can get from here, right? So the heat map shows that female athletes have significantly fewer medals across all types compared to the male athletes that you can see. So as we just discussed, this darker color, the lowest number of medals for females, and male athletes represented by lighter shade have won more medals in each category that you can see. Hope all of you are clear with this, right? How we can perform bivariate analysis if we have two categorical columns, right? Now let's move on. So now let's solve some more questions. Here we are going to consider numerical to numerical relationships. And here is the question. Here we have to display medal performance for a specific country per year. So let me first display our first row of our data set. And currently we are interested in this particular column, team, as per our question. So team, and we have to display medal performance for a specific country per year. So let's select country, India. You can select any. Let's execute this. You can see Pandas series with Boolean values. Let's pass this into our data frame to get actual values. You can see, and let's assign this data frame into one variable. df underscore India is equal to this statement. Let's execute this cell. Now df underscore India dot, let's perform group by year, and we are interested in medal count. Let's execute this cell. You can see, again let's assign it to one variable, India underscore medal. Let's execute this cell and let's use seaborne's line plot. And on x-axis, let me display this, let me copy this, let's paste it over here, let's execute this cell. You can see on x-axis we are interested in index, so let's copy this and let's paste it over here. On y-axis we are interested in values, this, let's copy this, let's paste it over here and done. Let's execute this cell. Now you can see medal performance for a specific country per year that you can see here. And we have selected India as a country. And here also you can give X label year, and also let's give Y label medal count. Let's execute this. You can see on x-axis we have years and on y-axis we have medal count. So please remember, for trends and calculations we are considering years as numerical values and count is numerical, right? So that's why here we are considering numerical to numerical relationships that you can see over here. So from this line plot, we can see that India's Olympic medal performance peaking around 1920s to 1950s, followed by a decline with slight recovery after 2000 that you can see over here. So this way we can find medal performance for a specific country per year that you can see over here. Now let's move on. So in this question, we are going to consider numerical to categorical relationships. And here is the question. Here we have to display the top 10 athletes by medals won. So let's display first row of our data set. And we are interested in name of the athlete. You can see, and let's use value counts. And let's convert this into Pandas data frame using reset underscore index method. Let's execute this cell. You can see, and let's assign it to one variable, medal underscore counts is equal to this statement. Let's execute this cell. Let's display this. You can see column names. Let's change this dot columns and let's change it to athlete and medal underscore count. You can give any. Let's execute this cell. Let's check. Let's copy. Let's paste it over here. And you can see column names for this particular data frame. And you can see top 10 athletes by number of medals won, that you can see over here. But let's visualize it, because it is always better practice to visualize it. So for that, let's use Seaborn's bar plot. On x-axis, let's pass medal underscore count, this column, and on y-axis let's pass this column, athlete. Let's copy and paste it over here, and data equal to this particular pandas data frame that just we have created. Let's copy, let's paste it over here, and you can see, as per our question, we are interested in the top 10 athletes by medals won. So here let's use head method with argument 10. Let's execute this cell. You can see over here, top 10 athletes by number of medals won, that you can see over here. Top 10 athletes as per medal count, that you can see over here. So this way we can display top 10 athletes by medals won, that you can see over here. And here medal count, which is numerical column, and athlete name, which is categorical column, having many categories, right? Now let's move on to our next question. So in this question, we have to find and display the count of medals, bronze, silver and gold, won in each city. And we have to present the results in a table format. Here city, that you can see in our data set. City means host city, right? So now let's display first row of our data set, and we have to perform group by city and medal, and we have to use size method. Let's execute this cell. You can see over here. So please remember, size method in pandas is used to count the number of entries in each group created by the group by method, right? And you can see this table is multi-level index table. So let's convert it into proper readable form. So for that, we have to use unstack method of pandas data frame. Let's execute this cell. You can see over here. Now it's look better. So as we just discussed, size method in pandas is used to count the number of entries in each group created by the group by method. And here we have used unstack method. So here unstack method in pandas is used to reshape the data in a data frame. It converts multi-level index created by group by into a more readable format by moving one of the level of the index into columns, that you can see over here, right? And as you can see the result, the different medals including gold, silver and bronze won in various cities, host cities, that you can see over here, right? So this way we can find and display the count of medals, bronze, silver and gold won in each city, and also we have presented this into a table format, that you can see over here. Now let's move on to our next question. Here we have to sort the medal counts per city based on the total number of medals, bronze, silver and gold. In short, we have to sort this table into ascending or descending order. We will sort it into descending order, right? Because we want highest total on the top. So let's copy this and let's paste it over here. Let's assign it to one variable, medal underscore count is equal to this statement. Let's execute this cell. Let's copy, let's paste it over here. Let's execute this cell. You can see, and now we have to find the total. So let's copy this, bronze, let's paste it over here, gold and silver. And here we have to perform sum. Axis is equal to 1. And let's create new column in this data frame with name total is equal to this statement. So here we are creating one more column with name total. Let's execute this cell. Let's copy this and let's check. You can see over here total. Now we want highest total at the top. So again here we have to use sort underscore values by total, and here we have to make ascending to false because we want in descending order. Let's execute this cell. You can see over here highest total in the host city London, that you can see over here. So you can see this is the way we can sort the medal counts per city based on the total number of medals, bronze, silver and gold, that you can see over here. And highest at the top. Hope all of you are clear on how to perform univariate, bivariate and multivariate analysis, right? So here is an assignment for you. As you can see, dataset which is available on Kaggle, regression of used car prices. You can download this dataset from Kaggle that you can see over here by pressing this download button. Also, you can download it from my GitHub account. Link is provided in the description of this video. And try out the analysis we just talked about, univariate, bivariate and multivariate analysis. Once you are done, upload it to your GitHub and paste the link in the comment section of this video. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye-bye. See you in the next video.